This is AP Calculus Worksheet 7-2 Solutions. So we need to explain what this thing means. So the integral from 20 to 40 of a function of velocity with respect to time, dt, this means this thing is the total change in position. And that's the main thing, total change in position, but I'm not done. Total change in position and we're in meters here. So in meters. And then when does this happen? It happens from time 20 seconds to 40 seconds. And I guess it kind of sounds a little bit weird to say time. You could have said from 20 seconds to 40 seconds. How far did I change? The total change in position. And that was problem number 1. Let's go to problem number 2. Kind of the same thing, so explain this meaning for the rocket's flight. So the integral from 10 to 70 of that velocity function vt dt is, again, it's the total change in position. And that's the key, total change in position. And I guess if you're being specific, since we know it's a rocket, it would be height. We know that position is either a variable with x or a variable with y. If it's a rocket's flight, it's probably going to be y, unless it's flying horizontally, like to another continent or something. And what is our unit? It's in feet. And that happens from we're from 10 to 70 seconds. From 10 seconds to 70 seconds. And we're on to number 3. So same type of thing. So integral from 0 to 40 of that velocity function vt dt. That is the, again, total change in position. You need to write this over and over again. This is the definition that you need to know. Total change in position we're in miles here, in miles, from 0 minutes to 40 minutes. Again, this is problem number 4. We have a very similar problem. It's just asking the same thing, only instead of a table or something, they give us a graph. But the answer is still the same. So the integral from 0 to 50 of velocity with respect to time, dt, that means the total change in position. And total change in position is the key words that you need to remember, and that's between, or what is our unit? I think that says feet. It's hard to see because it's kind of low quality. In feet, from 0 seconds, we're in seconds to 50 seconds. And on to number 5. So now we actually have to find what the integral is. That means that we're dividing it up the shape into regions here. And I like to make my regions into rectangles so I don't make a mistake. And I'm going to shade in the area that I'm actually looking for so I don't make a mistake. Alright, so our first shape here is 4 by 20, the rectangle, and then that's going to be 80. Half of 80 is going to be 40. And then this rectangle is 4 to 16, so that's 12. 12 times 20 is 240. And then 16 to 24 is 8. 8 times 20 is 160. Half of that is going to be 80, so it's 80. And so this is equal to 40 plus 240 plus 80. 40 plus 240 is 280, plus 80 is 360. And don't forget your units, so we went and took the integral, so we're going backwards from velocity, which means we're in just meters. And using correct units to explain this meaning, so this is the same exact thing. 0 to 24 of velocity, going backwards from velocity, we get, hold on, dt means when you go backwards, it's the total change in position. Position is the antiderivative of velocity. Position. And what units are we in? In meters. In meters from 0 seconds to 24 seconds. And on to number 6. So in this one, for part A, we're explaining this. Okay, it's a little bit different now. It's not velocity, it's acceleration. So integral from 0 to 30 of acceleration with respect to time, dt. What does that mean? Now that's the total change in, it was position, velocity turned into position, but acceleration now, when you take the antiderivative, turns into velocity. So it's total change in velocity. And again, that is the key part, change in, or total change in velocity. Whew, include that in there. And that is now in feet per second. And that is from 0 seconds to 30 seconds. And then part B, we have to do some calculations, so I need to evaluate this. So when I have integral from 0 to 30 of acceleration with respect to time, dt, when I actually take the antiderivative, that is going to turn into velocity, just like we said up in part A, and that's going to be evaluated between 0 and 30. So when we do that, so I'm going to first plug in 30, so v plugging in 30, and I'm just going to leave it like that for now, and I'm going to subtract when I plug in 0, so velocity at time equals 0. Alright, now let's actually do the math. Well, there's not really math, but what happens at time equals 30? At time equals 30, what is velocity? V, not A. So velocity at 30 is negative 14. So negative 14 goes here. I'm going to subtract V0, that's negative 20, negative 20. Negatives kiss turns into a positive, and that's going to be 6. Don't forget our units. Velocity is always in feet per second. On to number 7. Alright, ooh, a little bit different. So we are given velocity, and it's asking for the graph of position here of the particle in that time frame. Alright, so what is velocity in terms of the graphs that we're given? So in terms of position, velocity is the slope of position. So what you're really looking for is, are all these slopes met by one of these graphs? So a really good one to start with is, a slope of 0. So that means I'm going to have this horizontal tangent like this, or there, or like this, there. So I'm looking for that at position 3. So 1, 2, 3, slope is not 0. 1, 2, 3, slope is not 0. 1, 2, 3, slope is 0, could be C. 1, 2, 3, slope is not 0, can't be D, and 1, 2, 3, okay, it could be E or C. Which one is it? So now we need another point to look at. And I notice here that the main difference between the two graphs is at 1. So at 1, I have a slope of 0 at E, and at 1 I have a positive slope on C. So this is not a 0, it's a 2, so it can't be E. It's not a horizontal tangent right here, so the correct answer is C. And on to number 8. Alright, what are we given? We have a constant positive acceleration. Alright, that means that we have an F double prime is greater than 0. And we are given a graph of the distance. So in terms of a graph of a distance, since that's what all these are, what is the second derivative? Is it slope? Is it height? Is it concavity? You should know that the second derivative is concavity. So where do I have concave up? So look, I have concave up in A, could be A, can't be B, it's not, there's no concavity. It could be C, that's concave up, can't be D, also doesn't have concavity, can't be E, that doesn't have any concavity. So how do we choose between A and C? Well, look at this initial condition. 2, 0, and that's just on the x-axis, so it's just in terms of a graph. So 2, 0, that's C. And on to number 9. I know we did this in class, but I'm just going to make a video for it anyway. So I need to find the average velocity. So what is average velocity? What is the definition? So that is the definition is the total change in position over the total change in time. All right, the way that we're going to find the total change in position is by looking at position 1 and position 2. So we're given position. Position is this equation. So it's like saying that x of t is equal to negative 5t squared. So we just need to plug in things into our equation, and it's between 0 and 3, so we need to find x of 3 minus x of 0. And that's all going to be divided by 3 minus 0. That's the change in time. All right, so what happens when we actually plug in 3 into our equation? When we plug in 3 into this equation, we get 3 squared is 9. 9 times negative 5 is a negative 45. Subtract, when I plug in 0, I get 0. All that's going to be divided by 3, so the answer here is negative 15. And finally on to number 10. So I'm looking for the average velocity. So average velocity, the definition is the total change in position, all divided by the total change in time. Change in time. All right, so that's going to equal, we don't have a position, we just have velocity, so we have to integrate this, and oh dear God, that is hard. Yeah, we just need to use a calculator, and the clue here is whenever you have decimals, you're going to be using a calculator. So to integrate this, I'll go through the steps on the calculator in a sec, but essentially what you're going to do is you're going to do the integral, and it's from 0 to 3, from 0 to 3 of that function, so of e to the power of t plus t e to the power of t. And we can calculate what that is on our calculator, and that's all going to be divided by total change in time is 3 to 0, or 0 to 3, so 3 minus 0. All right, so let's plug this in on our calculator. How do I do that? So pulling up our calculator, I first need to enter this equation, so I go to y equals, and I need to plug in e to the power of t, so second natural log, that's e to the power of, and this variable button will work even though it says x, that'll be fine. End the parenthesis here, and that's going to be plus that variable times, and when you do times you just kind of leave that blank, times e to the power of the same variable. Alright, so I have my equation entered. I'm going to go ahead and exit by doing second mode to hit quit. And now I need to take the function to take the integral. The way that I do that is I hit math, I go down and hit, is it 8 or 9? I always forget. I can scroll down and say it's 9. So if I just hit 9, that'll work. It's the integral, and then I have to say the function. To get to the function, to get to this y1 function, the way that I do that is I go to vars, I scroll over to yvars, hit function, hit enter to hit y1. So it's saying this function with respect to what variable? With respect to x, comma, and beginning and start. So, or beginning and end. So from 0 to 3. So 0, comma, 3. And then you don't need to close this, but I'm going to. And you hit enter. Perfect, we get 60 point, I'm going to round to just 0.26, sounds good. So this is going to equal 60.2, I shouldn't do equal, it is approximately 60.26 divided by 3, and that is equal to, and I'm just going to divide that by 3, and we get 20.086, and that's what our answer is for A. That is 20.086.